So this is exercise related to rate or the speed of the reaction. This part, the MCQs we already discussed. Some questions we'll discuss. Okay, in this, look, it's not necessary you have the same question what you studied. They will ask applications also what you studied. So you have to use your understanding to answer these questions. In a question, when aqueous sodium thiosulfate and dilute hydrochloric acid are mixed, a precipitate means when you mix two solution, a solid is formed. If a solid is formed, this solid is known as precipitate. So when sodium thiosulfate, this substance Na2S2O3, it's called sodium thiosulfate, and hydrochloric acid, this is HCl. They mix with each other. This result in a formation of a precipitate. Precipitate, again, it means a solid which is formed by mixing two solutions. So sulfur solid is formed. So when the sulfur solid will form, what will happen? If you are looking from the top through this conical flask, as the sulfur start to form, the cross which is under the conical flask will disappear. Why it will disappear? Because as a precipitate or solid is formed, so light is not able to pass through and you are not able to observe this cross through this conical flask. So what happened? The cross will disappear. If cross will disappear in a short time, if it take less time for the cross to disappear, it means the reaction is fast. If a cross is taking more time to disappear, it means the reaction is slow. Because if a cross take short time to disappear, it means sulfur is formed quickly. If a cross take more time to disappear, it means sulfur is formed slowly. As a sulfur is formed slowly, it shows sulfur is a product. It shows that it is a slow reaction. You don't have to learn or memorize this equation. This equation will be there. A student add the following volumes of sodium thiosulfate, hydrochloric acid, and water in a conical flask. So what he did, he used sodium thiosulfate. Sodium thiosulfate is Na2S2O3. Then hydrochloric acid is there and water. He mixed all of them together. The time taken for formation of a precipitate of sulfur, means solid sulfur, to make the cross disappear, V is recorded. So we record how much time the sulfur will take to disappear. If reaction is faster, the sulfur will disappear in a short time. So this is stopwatch. State the order in which the sodium thiosulfate, hydrochloric acid, and distilled water should be added. In this question, you can see the distilled water is not a reactant here. You cannot see in the reactant side water is there. What is the purpose of adding a distilled water? Because we are repeating the experiment, or we are doing the experiment 3 times. You can see experiment 1, experiment 2, and experiment 3. So 3 experiments are there, experiment 1, 2, and 3. So what is the purpose of the water? Because we want the fair comparison for all the 3 experiments. That's why we want the total volume of a solution to be same. Example, if I took 10 cm cube of thiosulfate and I took 10 cm cube of hydrochloric acid, we are changing only the amount of thiosulfate. Hydrochloric acid is fixed. So what volume we took for water? We took volume of water 40 cm cube. So when we take the volume of the water 40 cm cube, so what it shows? It shows that the total volume of the solution will become 60. Same thing, if thiosulfate or sodium thiosulfate is 20 and we took 10 cm cube of hydrochloric acid. So how much water we took? Because we want all the experiments should have the total volume same so that we can compare the amounts and identify the speed or the rate of the reaction. That's why in the third experiment, we took 30 cm cube of water. For example, if I use 40 cm cube of thiosulfate and I took 10 cm cube of, or for example, I took 30 cm cube of thiosulfate and I took 10 cm cube of HCl. We are not changing HCl, we are only changing thiosulfate. How much water I should take for the fair comparison of this experiment? If I took 30 cm cube of thiosulfate and 10 cm cube of hydrochloric acid, how much water should be there? So water should be 20 cm cube because 30 plus 10, 40, 40 plus 20, it will make 60. Same thing, if it was 40 cm cube and 10 cm cube hydrochloric acid, how much water should be there? So the water should be 10 cm cube so that the total volume for each experiment will be same. So purpose of the water is to make the total or the final volume same so that the one which is having a higher proportion in the mixture will have more concentration or greater amount. So which order, the question is which order we should add, because sodium thiosulfate and hydrochloric acid are the reactant. The purpose of the water is to make the solution final volume same for each experiment. So which order we should add them? What I should add first? We have sodium thiosulfate, hydrochloric acid, and distilled water. Water is just to make the total volume same for that all the reaction mixtures. So which order we should add? Because the water is not a reactant, water is just making the final volume same. So which order we should react or which order we should add? So example, if you add thiosulfate first, in a conical flask you add thiosulfate, then you will not add hydrochloric acid directly. What is the reason why you should not add hydrochloric acid directly? Because if you add sodium thiosulfate with hydrochloric acid, the reaction will start. So addition of the water will not make much difference to the rate. That is why we should not add both reactants together. It can be any order, but not together. So you can add water first. You can add water. Then you add thiosulfate. And at the last, you can add hydrochloric acid. This is one combination. Or what you can do, you can add thiosulfate. You can add distilled water at the second. And at the last, you can add hydrochloric acid. So that the reason for not adding thiosulfate and hydrochloric acid at first, otherwise they will react with each other and the reaction start and the products start to form, and addition of the water will not make any difference to the rate or the speed of the reaction. Is it clear? So the order in which we should add, it can be thiosulfate. It should be thiosulfate first, then we can add distilled water, and then we can add hydrochloric acid. Or it can be water first, distilled water first, then it can be thiosulfate, it can be hydrochloric acid. Or you can add distilled water, you can add hydrochloric acid, and third, you can add sodium thiosulfate. but not all these two, sodium thiosulfate and hydrochloric acid at first. That combination is not acceptable. Other than that, all the combinations are acceptable. In experiment 3, student wanted the sodium thiosulfate to be double concentration used in experiment 2. So what is a double of 20? So double of 20 is 40. So how much? So double of 20 is 40. So student use 40 cm cube of thiosulfate. And hydrochloric acid volume is not changed. It's 10. So how much volume is there for distilled water? What should be the volume of a distilled water used in this experiment? So it will be 10. Now complete the table to show the volume and expected time. So expected time, how you can find the expected time? If I use more thiosulfate, as we know, if we use more reactant, if we use more amount, then the rate will be a greater amount. If we use, then it will increase the rate. So as the rate increase, the time for the cross to disappear will increase or decrease. If the speed of a reaction is faster, the cross will disappear in a short time or take more time. So time for the cross to disappear will decrease because it will form precipitate faster. So example, if the volume is double, if the concentration is double, the time will be half. So what is half? If it is taking 28 seconds when it was the thiosulfate was 20, but we double the amount of thiosulfate, we make the thiosulfate 40. So how much time it will take to disappear? It will be divided by 2. So if the amount is double, the time for the cross disappear will be half. So if it was taking, when it was 20 cm cube of thiosulfate, taking 28 seconds to disappear, but if you use 40 cm cube of thiosulfate, it will disappear in 14 seconds. So it will take a short time to disappear. And use the collision theory. Is it clear? You can also solve from the first value. You will get the same answer. How you can use the first value? Compared to the first value, it is 4 times, because it is 40 means 4 times. So if the volume is 4 times or amount is 4 times, it means the time for cross to disappear will decrease by 4. Because if rate is faster, the time for the cross to disappear will be shorter. So if 56 divided by 4, again I will get 14. So we'll get the same answer. You can compare first experiment with third experiment or second experiment with third experiment. It will not make difference. When we are comparing the second experiment with the third experiment, because compared to the second experiment, the volume amount is double. So if amount is double, the time for the cross to disappear will be half. So if it was 28, then it will be divided by 2. So it will become 14. Is this clear? Part B. Next is use the collision theory. Explain why the increasing the concentration would increase the rate. So in terms of collision theory, how we state increasing a concentration will increase number of the particles and collision between the particles which results faster rate. A student repeated the experiment at a higher temperature. Using a collision theory, why the rate will increase as we increase the temperature? So increase in temperature, increase kinetic energy or speed of the particle. Or speed of the particles. So they collide more often with each other, which result faster rate. Okay, in this experiment, question 2, magnesium carbonate react with dilute hydrochloric acid. Excess of magnesium carbonate is placed, carbonate pieces are added to hydrochloric acid. The volume in the diagram are used to measure the volume of a gas produced. The total volume of a gas collected were every 20 seconds. Describe how the rate of a reaction changes during a reaction and explain why the rate changes in this way. So what is the reason why the rate of a reaction changes and why it changes in this way? And this is a 4-mark question. So in the beginning, the rate is faster. At the start, then it slowed down as number of particles decrease, because in the beginning you have more particles as a reactant are forming a product. The number of the particles or reactant particle and stops when hydrochloric acid completely reactant is faster at the start, or reaction is slow down as a number of the particle decreases, and eventually as all of the hydrochloric acid used up. Why we specifically use hydrochloric acid used up? Because in the question they mention excess of magnesium means magnesium carbonate. So means magnesium carbonate is more than enough for this reaction to occur. So even when the reaction stops, still we will have a pieces of magnesium carbonate, but all of the hydrochloric acid will be used up. The experiment was repeated with the same mass of magnesium carbonate and same volume and concentration of hydrochloric acid, because what we did, But what we have powder magnesium. So if we are using a powder magnesium, it will have large surface area, so reaction will be faster. So if I say we use a powder magnesium, what is the expected graph or a graph you expect? So it will be steeper because powder magnesium will have large surface area. So it will be steeper, but the final volume will be same, or final amount will be same. So answer here, what happened to initial rate? Initial rate means starting. So initial rate or starting experiment, it will be steeper or faster because large surface area increase effective collagen. What about the total volume of the gas? It will be same because same number of particles react compared to experiment 1. So in the first experiment and in the second experiment, we took the same amount of reactant. That's why the reaction will be, or rate of the reaction will be, the amount of the product will be same. Is it clear? Any doubt in this? So faster for, or higher because large surface area, and same volume because same amount of hydrochloric acid is used. In the next part, a piece of magnesium ribbon was cleaned. The experiment was repeated using this clean magnesium ribbon instead of magnesium carbonate. The reaction is exothermic. Exothermic reaction means it will give out heat energy. The rate of reaction gradually increases over the first 2 minutes. Means what happened? Explain why the rate of a reaction increases. So what is the reason? What happened, like if we are using a magnesium react with hydrochloric acid? So a graph is a bit different. So when magnesium is reacting with hydrochloric acid, what we observe in the beginning, it is slower, and then for first 2 minutes it increases and then it decreases. Why this part is there? What is the reason for that? First it increases and then it decreases. So what is the reason? The answer is given in the question. They mention the reaction is exothermic. Exothermic reactions give out heat energy. So basically what happened, as the reaction is exothermic, so temperature of the mixture will increase. Exothermic reaction, temperature of the mixture increases or rise. So particle will collide more often, or there are more collisions between the particle, or particles have sufficient energy to react. So that's why it will result in more collision or successful collision. So what happened? The reaction is exothermic. So energy is given out temperature of the mixture will increase. This will result in higher kinetic energy or speed, which leads to more collision between the particles, increase the rate of reaction. Is this clear? So because the reaction is exothermic, so exothermic reaction in the beginning it is slower, but because it releases energy, that energy which is released absorbed by the particle and increase the kinetic energy of the particle or speed of the particle. As these particles have higher kinetic energy or speed, so they will collide more often. Afif, why you cannot say magnesium was covered with a oxide layer, so it was unreactive in the beginning? Because they mention a piece of magnesium ribbon was cleaned. What does it means? It means that you remove the oxide layer on the surface. Clean magnesium, normally what happens when you have a piece of magnesium, this magnesium can react with oxygen in the atmosphere and it can develop an oxide layer. So top part of magnesium is magnesium oxide because it reacted with oxygen in our atmosphere. So this will be magnesium oxide. So what is the meaning of clean magnesium? Clean magnesium means that we remove this oxide layer and we have only magnesium. Magnesium is a metal and magnesium carbonate is a salt. It's a compound. This is magnesium is an element, magnesium carbonate is a compound. Magnesium, when magnesium carbonate react with hydrochloric acid, it was giving carbon dioxide. But when magnesium was reacting with hydrochloric acid, when metal react with acid, it will give hydrogen gas. Is this clear? A student investigate the progress of a reaction between hydrochloric acid and calcium carbonate or a limestone. The graph shows an excess of, so we use more than enough calcium carbonate. How does the shape of a graph shows that the rate of reaction decreases as a reaction progress? Shape of the graph, as we know, the slope is equals to rate, slope or gradient. So slope or gradient is equals to rate or the speed of the reaction. So how the shape of the graph shows that the rate of reaction decrease? Because the gradient or the slope is decreasing, which shows rate is also decreasing. The rate of the reaction is equals to the slope or the gradient. You can see angle here, it's much steeper, but as we take different points, we find that the angle is decreasing. So if angle decrease, it means the slope decrease. And why the rate of a reaction decreases as the reaction progress? Because the number of the particles of reactant decrease. That's why the rate of a reaction will decrease. And how many seconds did the reaction finish? Reaction finish means when the volume is constant. So when the volume is constant, it's about 120. When the volume start to be constant, it does not change after that. So it will be 120 as an answer. Is this clear? This part? Here number of particle decrease. And here the slope decrease. Any doubt in this?